Okay, we'll start now since I guess we have a sufficient amount of people to start. Uh, okay, let's just start off here. Okay, let's just start now. Um, Good afternoon, everyone. Thank you all for attending today's workshop. My name is Omar. I'm part of the GDG team. I'm both in IDU. I'm the social media lead here, and I'm also a DS or data science enthusiast. Today's workshop is actually going to be about building movie recommendation systems. So basically things such as the recommendation systems at Netflix or YouTube or Spotify or Amazon or any of these recommendation systems. So yeah, I guess we'll start. Have you guys ever wondered how Netflix seems to know exactly what you guys want to watch next, or how YouTube always recommends videos that match your interest? Just keep doing that, I guess, yeah. Recommends videos that match your interest. The secret behind all of this on how all these recommendation systems work is just the recommendation systems. What recommendation systems are basically they are a branch in AI that are designed to personalize content based on user preference. Today we're going to break down how these systems work, why they're important, and we're actually going to build one at the end. So to quickly go over the objectives of this workshop, we're gonna understand how these recommendation systems work. We're gonna train an SVD-based collaborative filtering model using Python. Yes, I'll explain what this is. Just give me a second. And we're going to predict and recommend movies for different users based on their preference. So by the end of this session, you will understand how recommendation systems work, learn how to train a recommendation model using Python, and be able to predict and recommend movies based on user preference. Um, don't worry if you don't have any prior experience with coding or Python. This workshop is designed for beginners, and we'll go slowly, step by step. If you have any questions, feel free to ask in the chat. So yeah, let's just get started. So before explaining how recommendation systems work, let's actually define what recommendation systems are. So for recommendation systems, a recommendation system is an AI-powered tool that predicts what a user might like based on whether music based on their past behavior. Think of it as this. Have you ever ordered food online on Talabat or the app keeps suggesting meals that is similar to your past orders? Or maybe when you're shopping on Amazon and you see the recommended for you section while filling the products that match your taste. Even in social media, I'll give it a minute, I guess. Even on social media, these posts you see are actually carefully selected based on what you've interacted with before. All of these are examples of recommendation systems at work. And we actually have a picture here of a recommendation system of Netflix. So you see the specific user has watched the movie Train Your Dragon, How to Train Your Dragon, and it gives him a recommendations on some other movies that he actually might like. So why are these recommendation systems important? Basically, in today's world, there are simply way too many choices. That Netflix alone has 17,000 titles worldwide. Spotify has more than 100 million songs. Amazon offers millions of products without millions of products. Without recommendation systems, users would be overwhelmed with these options, making it difficult to find what truly is enjoyable for them. These systems enhance the user experience by helping them discover content that they love, saving them time by eliminating the need to scroll endlessly to platforms. Whether it's streaming movies such as Netflix, uh, such as if it's streaming movies such as Netflix, or e-commerce such as Amazon, or even social media such as Instagram or Twitter, or any of these personalized ads. Recommendation systems play a crucial role in delivering the best content at the right time. So now that we defined what recommendation systems are, let's look into how do they work, basically. So there are three main approaches to building recommendation systems. The first is a content-based filtering which suggests items similar to what users have previously liked. For example, if you watch let's say sci-fi movies, the system will recommend more sci-fi movies. Or if you watch any drama movies, the system will recommend even more drama movies that you liked. Or even, for example, you can say Amazon, if you bought a keyboard, for example, if you can tell that it starts recommending more stuff that are similar to a keyboard. For example, mouses, desktops, monitors. These are all examples of content-based filtering. Another approach that we have is a collaborative filtering, which makes recommendations based on what similar users like. So if you and another person, for example, have watched 10 movies, 10 of the same movies, and the other one has watched an 11th movie that you actually haven't seen yet, the system might recommend that movie to you. This technique also works by comparing user behavior rather than just looking at the content. So, for example, if you and I have a shared playlist on Spotify, for example, that we listen to the same music, if I, for example, start listening to another song, to a new song, or some of Spotify's recommendation system might suggest this new song to you, since we already have a similar taste or similar, because we digest the same type of music. And the third approach is actually a hybrid approach, which is what Netflix and YouTube actually use. What it does is that it combines both content-based and collaborative filtering for better accuracy. And this is what Netflix and YouTube use to personalize recommendations. Not only considers what you like, but it also considers what other people like, which creates a highly accurate and personalized suggestions. Now, let's quickly wrap up our this presentation because let's just I'd much rather go into actual coding because this is the part where we're gonna understand more than just yapping. I'll be honest with you. I'll just go over quickly what we're gonna code today. We will be building a recommendation system from scratch. We will start with first off with exploratory data analysis. We're gonna explore movie data set and the ratings data sets. We have two data sets today to work on. We're going to understand the structure. This step also involves analyzing how many movies are available. Next, we will go into making the movie recommendations. So we're going to implement a model called the SVD-based collaborative filtering. I'll explain it while doing the workshop. So while we're coding, I'll explain what SVD means, all of that. Don't worry. And after that, we're going to train our model, and then at the end, we're going to apply this machine learning techniques to get personalized recommendations for different users. And yeah, that's that. Now that we've covered all the fundamentals for recommendation systems, it's time to actually put theory into practice. Let me just quickly stop sharing, and I will share the other screen, basically. And yeah, so what I want you guys to do is can everyone mute chat, please? Mute your mic. Someone here has their mic open. Yeah, thank you so much. So what we're going to do is we're going to go into Google Colab and we're going to do into this link, the Google Colab, the second link that we can get, and we're going to press on this button, new notebook. We're going to create a new notebook, and you might ask, why are we using Google Colab? Well, it's first off, it's an open source IDE that you can run on your browser, so you don't need to download anything. And most importantly, it's free to everyone, and we don't have to download any libraries onto your machine. So it's pretty lightweight. And we'll actually just immediately start get into coding, and we're gonna first first thing we're gonna do is that we're gonna import these libraries. So we're gonna just write pip install, and the first library we're gonna download is the NumPy library. And specifically, we're gonna download the older version. Now, if you ask why we're downloading the older version of NumPy, well, the recommendation system that we're using, which is called Surprise, is actually runs on the older version of NumPy. So we need to downgrade to the older version of NumPy for this recommendation system, or specifically for this workshop to work. Um, what other else? Yeah, so we have scikit-learn or scikit-surprise, sorry. Uh, no. And what we're gonna do, so basically to run a code cell, we're going to press on this play button. This is what this is going to do is that it's going to basically run your code or interpret your code. Now, for the first code that you're gonna run, it might take you a second. As you can see here, it says connecting or just connected for me. It's gonna give you a second for it to connect, and as you can see, it's downloading libraries. It's gonna take like a minute, so give it some time. And while we're waiting for it, what I want you guys to do, or what I'm about to do right now is, oh, and you might get this pop-up which calls restart session, which is totally fine by the way. It's just because we're downgraded to another version. What it's going to do is that we're just gonna have to press on it again, just rerun it again. There's no way this is no. What I'm going to do now is I'm gonna send you the data set on the Microsoft Teams, the two data sets. And what I want you guys to do is I want you to download these data sets because these are the data sets we're going to use. Uh, these, if it loads, yeah, okay, these two. And yeah, I just sent it. So if you guys could quickly download these data sets while this is running, I could go find the version. Okay, this is fine. Just give it a sec. Uh, just let me test quickly actually. Before this, you guys press on this file icon and go into upload session storage. And here we're going to download or upload the data sets that we just downloaded. So the ratings and the movie data sets. It's gonna give you a warning, it's fine. It just says that you need to save these. We already saved them in our machine. Just gonna run this quickly just to make sure that everything runs correctly. Huh. Well, let me just grab this here. Actually, this is the same code and it runs. So I don't know why it's not running here. If it gives me some error, that means it's fine. Oh, okay, never mind. Okay, so never mind. I guess something was wrong in the writing, but yeah, it's fine. You guys can just copy paste this. And if you guys get the same error, just I'll send you guys the exact same code right here in the chat, and you can just copy and paste it. So yeah, as you can see, this green arrow it just shows which line it's currently interpreting. So it finished the first line, now it's currently interpreting the second line, and it's gonna I gotta give it some time for it to load. And while it's loading, let me just show you some features for Google Colab. Um, so for example, this is what we have here. It's called a cell. So we have two types of cells. We have a code cell and a text cell. This right here we have is a code cell where it says right here start coding. So what you can do is that you can just write Python code, for example. You can just write hi, and it's gonna run. It's kind of slow right now because it's currently running the one above. But yeah, basically yeah. Uh, so yeah, you also have another type of code cell, which is called a different type of cell, which is called a text cell. So we can just write comments here, which gives us a much better UI than just writing code, than just writing comments, you know? Here it says, oh, I even have a code spelling. This one. Yeah, much better. See? Hello, evening. Perfect. And yeah, as you see, the code cell runs, the libraries are fully installed. And since we don't really need this was just to show you guys how code cells work. You can just press on this delete cell, or what it's going to do is that it's going to delete this cell. The same thing here. I don't need this hello evening. Doesn't even make sense. So what we're going to do now is we're going to import some libraries. So first library we're gonna import is pandas. The second one is the NumPy library that we just installed. The third one is the surprise library, which actually has the recommendation system. So this is the library that we're gonna use to basically build the AI model. We're gonna import certain things from it, such as specifically the SVD model. We're gonna okay, I didn't say import. Oh, I have to say it from here. Yeah. Okay. So you have SVD, you have the data set, which is gonna convert a pandas data frame into a surprise data set. I'll explain it just later on when we're gonna use it. I'll explain it much further. We're gonna explain a reader. So we're gonna use a reader and we're gonna import another thing called accuracy, which is the thing we're gonna use to test the accuracy of our model. So see how accurate our model is. Also, we're gonna use the surprise model. Let me, yeah, model action, and we're gonna import the train test split method. So it splits our data set into, yeah, here we go. It splits our splits our data set into a training set and a testing set. And we're gonna run this. Anyway, you get a green check mark. So that just says that your code runs and there's no errors in it. So now what we're going to do is that we want to import these CSV files into actual data frames. So basically what data frames are they're a type of data structure that's basically like an Excel sheet or basically like a CSV table, but we're just importing it into a pandas via data frame so we can actually manipulate the data inside it. So we're gonna make a variable called movies, which is where we're gonna store this data set. We're gonna call this the pandas library. We're gonna call this method called read CSV, which is self-explanatory. We just read the CSV file. And what we're going to need to put here is the path of this file. So what I want you to do is press on this files icon, go into these two CSV files that you guys just uploaded. Um, Press on these three dots, and you press here, copy path, and it's gonna copy straight to your clipboard. So you're just gonna go here, uh, and just paste it. Yeah. And we're gonna do the exact same thing with the ratings. So we're gonna make a variable for the ratings variable, and yeah, and we're gonna do the exact same thing. We're gonna copy the path from the ratings data set, and we're gonna put it here. And perfect, it runs. So just to check the format of this table, what we're gonna do is that we're gonna use the head method, which is gonna show us only the first 10 rows of this table. And it's just gonna show us like right here. Okay, so it printed perfectly. It imported perfectly. The number inside the parameter is just how many rows that you want. So if I can just write 3, and it only shows 3 rows. If I write 20, for example, it shows, yeah, it shows 20 rows. We're just we're just writing 10, so we just get it's like a good in-between number basically. And we're just gonna do the same thing for the ratings table. Or actually no. Let's look into the movie data set first. So we're gonna use a method called describe. And what this method actually does is it gives us a summary statistics of all the numerical variables in this data set. So right here we have 3 columns. We have movie ID, title, and genre. As you can see, only one of them is numerical. The other two are text-based or qualitative, basically, if we're going to use statistics wording. What it basically means is that these use text data, and this is numbers. Pretty self-explanatory. So what this describe method does is that it does a summary statistics on all the numerical columns. So right here we only have the movie ID column, so that's why we only see the movie ID here. And it gives us just the statistics on this column. So example, it gives us the average, the count, so like how many rows of this movie ID. So we can tell there's 9,742 unique movies. And yeah, so what we're going to do is that we're going to check first off for this uh, column, movie ID. We want to check if there's any duplicates in it, since obviously it is a ID, so we don't want any type of duplicates. So what we're gonna use the unique method. Yeah, and we're just gonna run it. So what this basically does, it shows the number of unique variables in this column, or how many unique rows are in this column. So we can tell from here is that in this movie data set, we have 9,742 unique, or we have 9,742 rows, this number of rows in this table. And as you can see, we have now the same number of unique variables. So what we can tell or we can interpret from this is that every single row has a unique movie ID, which is perfect. This is what we want. The second thing we want to do now is we want to do the same thing, but we just want to see the data set for the ratings data set. We just want to see if it loaded in well. And we want to see like the columns, the rows and stuff. So for example, for the ratings data set, we have four columns. We have the user ID. So for the specific user, what gave the rating, what is their ID? What movie did they rate? So for example, the movie ID is one. If you go here, movie ID one is Toy Story. So user ID number one rated the movie Toy Story a 4 stars, 4 out of 5. And the last column is actually the date. Now, what this does, as you can see, it shows a date and a specific timestamp. What it does is that it shows the specific time the user left a review or left a rating. So, to show an example, so user one left a 4 star rating on Toy Story at 18. Actually, I can't really read this, but if you use horizontal military timing, 18 hours in the year 2000. This is actually pretty useful. We can use this to basically interpret maybe some users give certain ratings during specific times of the year. So, for example, at Christmas, they maybe give higher ratings to Christmas movies or to horror movies at Halloween. We can use this to maybe see customer data and see what they prefer at different seasons. And now that we check both of these data sets, what we're going to do is that we're going to merge them. So instead of having two tables, we're going to have one giant table because it's just going to be way easier for us to work with one table instead of two tables. So what we're going to do is that we're going to mention the first table. We're going to use the method called merge, which is going to merge these two tables, and we're going to mention the other table that we want to merge it with. And we want to mention what type of column we want to merge it on. So basically, we want to map every single value to every single other value in the other data set. So for example, here we use the movie ID column. Since both of these, as you can see, both of these tables have the movie ID column right here. So for example, we can see that the user ID, if we map them together, the user one ID rated the movie ID, which right here is actually Toy Story, and you can show the genres of the movie. So Toy Story is adventure, animation, children, etc. And the ratings and everything. It combines everything all into one table. And now this is what I'm gonna show you right now. So yeah, I'm just gonna write df so it shows the table. Actually, I'm just gonna use head so it's much more readable so you guys can understand it better. So here you go. We what we did is that we included these two tables into one singular table. So just to go over what I just mentioned. So basically, user ID number one rated the movie ID, which is Toy Story, a 4 stars, and this is the exact same date that or exact same second the user gave a rating, and it has the genres because it helps us better classify user preferences. So, for example, if we know that user one gives high ratings on children genres or comedy genres, we can tell, okay, maybe he likes genres. We can recommend them other movies that are from the same genre. Now, actually, we just finished processing the two data sets. What we're going to do is that we're going to make a copy of these two data sets of this data set after we clean it. It's just a good habit, just copying data sets. Just in case if you make a mistake later on while maybe you're deleted too many columns or you removed like some amount of rows or you just corrupted the data, you can immediately just go back to this checkpoint. You can just think of this as a checkpoint. So yeah, so what we're going to do next is gonna do the exact same thing again. We're gonna use the describe method. But now we're going to look at the two data sets as a whole. We're going to look at the summary statistics as a whole. So as you can see now, the count for this data set is actually different now. It has 100,000 rows. So if you can see that for the first data set, it had what 9,000 rows. And now after we combine them, it has 100,000 rows. So obviously now we have more data, which is better for us. We can make more personalized recommendations. Next, what we're going to do is that we want to see if there's any null values. So basically, if there's any missing values in these two data sets, in this one data set, sorry, since we combine them, we just call them one data set. Or I just call them data set process because this is why I named them here. So what we're going to do is that we're going to use a method called isNull. And what it does, it's a Boolean function, and it returns a true or false value for every single row that has a missing value. So for example, if this row has a missing value, it's going to return true. So it means, yes, there is a null value in this row. And if the other one doesn't have any missing values, it's going to give false. But as you can see, if you run this, okay, never, it's not defined. Oh, I didn't run this. I have to run this first. Uh, it is not mentioned. Maybe it's a spelling mistake. Yeah, okay, it was a spelling mistake. As you can see, it's really unreadable if we do it like this, because it's giving us too much information. It's giving us false, like every single false here. False here means that no, this is not a null value. So what we're going to do is that we're going to use another method called the sum method. What is it going to do? It's going to sum all the null values in every single column and give us the number of null values. So if we run it now, yeah, right here. So it gives us the number of null values in every single column. So for example, in user ID, we have zero null values. So that means we have not a single missing value in the user ID column. And same with everything else, as you can see. Now what we're going to do is that we check if there's any missing values. We're going to check how many duplicate values or duplicate rows that we have. Since this data is misleading, if we have duplicate rows, it might be biased. It might give us a bias. For example, if a person, we have a duplicate row that gave 5 stars, but the duplicated 10 times, it's going to skew the data. So we really need to check if if there's any duplicate rows that we have. So what we're going to do is that we're going to use the duplicated methods uh, in this to this data set, and we're going to do the exact same thing. We're going to sum all the duplicated values in every single column. Or in this row, and see it returns 0. So the difference between this, if you're confused why this return 0 to all columns, and this just gave us a normal 0, is that this returns the amount of missing values for every single column. But for this method, it returns the amount of duplicate rows for the entire data set, basically. So instead of splitting it into specific columns, this just returns us how many duplicate rows you have for the entire data set. And basically, yeah, that's basically we're done with the data processing. And we're just gonna do a quick visual. We just want to visualize our data. It's good though to visualize our data. It's a good habit, basically. It gives us a good representation of how our data looks like, how it's scaled, and we can get good information. We can get informative information on our data that we otherwise can get without these visualizations. So what we're going to do is that we're going to import another library, so which is matplotlib. It is a Python library which is used for data visualization, and we're going to import another library which is Seaborn, which is also used for data visualization. We're just gonna run it, and let me just check real quick if anyone has questions. All good. Okay, perfect. Okay, so first thing that we're gonna do is that we want to make a graph and to see what are the most rated movies. So we want to see which movie has the highest amount of ratings, basically, or the most amount of ratings. So what we're going to do is that we're going to create a variable called top movies, and what we're going to do, it basically shows the highest amount of the movie with the highest amount of reviews, or the most amount of reviews, sorry. So we're gonna specify this column. So we're only taking this column, which is the titles, so the names of the movie. And we're going to do is that we're going to use the value counts methods. And what it does is that it counts how every single how many times every single movie was mentioned. So if you can see right here, where is it? Okay, here. So every single, if you can see right here, it shows that a user, for example, rated Toy Story. For example, if another user, so example, user ID number 2, also rated Toy Story, so it will give us 2, and etc. So we'll just count how many reviews every single movie has. So this is what the movie the values.count method does. And what we're gonna do is that we just want to see the top 10. This is what the had this is what the had method does basically. We're just gonna see the highest 10 values of this data set of this column. And now we're just gonna actually just create the actual figure. So we want to specify the figure size, which is the dimensions. We're just gonna use 10 width and 6 height, or 5 actually. Doesn't matter honestly. Just this is just what other old people use. And we're gonna use a bar plot for this visualization or for this graph. For the x values, we're gonna put the actual index or the amount of ratings basically, so the numerical variables. So basically the number of ratings for every single movie. So we're gonna just use the index method here. And for the y, we want to put the labels or the names of the actual movies. So we want to see which movie has the highest rating and stuff. So yeah, we're just gonna put the values method. Let me just delete this so I can write it with you so I can at least I can slow down a little bit, see if some of you can catch up or if you guys are slow down a little bit. For the X label, we're gonna put it as number of ratings, and we're gonna do the exact same thing, but for the Y label. But for the we're gonna put the movie titles there. I haven't put on quotations yet. Title. And we're just gonna give a title for this graph. So we'll name it the top. Let me put quotations again. Top 10 most rated movies. And the last thing we're gonna do is we're just gonna write plot.show. So what this is gonna do is just show the plot that we just made. And here you go. Oh wait, I think I forgot something. Oh, let me just I have to give it a palette of color. We'll use woolworm. Um, oh, actually mixed them up. I actually put the values at the X value column and the index, the Y column. Yeah, much better. Now it's actually understandable. So you can see now the actual graph. The title of the graph is the top 10 most rated movies. On the X label, we have the number of ratings, and on the Y label, we have the actual movie titles. Let me just scroll up a little bit, maybe if you guys want to read the code, if you guys are still writing it. So it shows the number of ratings for every single movie. So what we can see is that Forrest Gump, which was released in 1994, has the highest number of ratings. And it shows the top 10 the highest number of movies. So for example, if you want to see the top 10 lowest movies, the rated movies, we can use the tail method. So instead of head, we had the head here, yeah. We can delete this and we can put tail. So instead of showing the top of the data set, we can show the end of the data set. And here, it shows the lowest rated movies. So Love is the worst rated movie in this. Damn. Anyways, yeah. So yeah, this is basically it for exploratory data analysis. Um, what we're gonna do now is we're gonna actually build the model now. So what we're gonna do is that we're gonna create something called a reader class. And what this reader class does is that it basically gives a rating scale for the model to help the model basically. So let me just finish writing it and I'll explain it to you. Okay. So what it does is that for the recommendation, so for the model to give you a good recommendation, it needs like a range to basically interpret these ratings. Think of a reader as basically as a translator that helps recommendation systems understand the ratings of your data set. So, for example, like imagine that you're a teacher and you're collecting movie ratings from students. Maybe some students are using a scale of 1 to 5, so from 1 star to 5 stars, and maybe other students are using a 0 to 10 scale, so from 0 stars to 10 stars. Sorry. If you want to compare the ratings, you're gonna have to unify this scale. Basically, we want them to all use the same scales. For example, if we're using a 0 to 10 scale, but the model thinks we're using a 0 to 5 scale, it's gonna think that 5 is the highest rating yet, and it's gonna think, oh, this is the best rating. This movie, I'm pretty sure this movie is the best movie. In reality, we're using a 0 to 10 scale, so this means that it's actually a pretty average movie, or even worse, it might if we get a value that's higher than 5, and we might throw an error, which is worse. That means that our model doesn't even work. So yeah, what we're going to do now is that we wanna put our data into the model. So we want to use an actual format that the model uses. Unfortunately, it doesn't accept pandas. What we were using the entire time is pandas. The recommendation system that we're using today doesn't support pandas. So what we're going to do is that we're gonna use something else called a dataset, which is a class that's given. It's basically the same thing. I don't want to overcomplicate it. Basically, this is another way to save this data. And we're using the method called load from DF or data frame. This method is basically built for people who want to move their data from pandas to this model. And what we're gonna do is we're gonna name this model. So we named our model df.processed, or sorry, our dataset, and we're gonna pass the three most important uh, columns. So for example, user ID. So we want to know which user the recommendation came from. Want to give the user the movie ID, so we want to know what movie they rated, and most importantly, we want to give the ratings. So what rating did they give? And we're just gonna pass the reader into this model basically. And yeah, so next what we're going to do is that we want to split our data or our data set into a training test and a testing set. Basically, what it does, a training set is the what the model uses to train its algorithm on. So basically, think of it as studying for an exam. So what the model does is that it trains itself and practices on this data, and then it tests its performance on the test set, and then sees how good its performance is, basically. And it basically sees, okay, if my performance is bad, okay, I need to go back to the training set and train again, basically. So what we're going to do now is that we're gonna make two variables. We're gonna make the train set and the test set, which is what we just explained. Or we're gonna use the train underscore test underscore split, which basically what it does is that it splits our data set into two data sets, the one for training and one for testing. And we pass our data, which is what we defined here. We're gonna pass it here, and we want to specify how big our test set is. We'll specify how big our test set is. So we have test underscore size. We're gonna give maybe 20%. Yeah, 20% seems good. Basically, this means that we're using 80% of our data to train on or to practice on, and then we're gonna use 10%, 20% of it to test. You can use other measurements or you can use other percentages. This is just the most used one, basically. I've seen some people use 50/50. I've seen people use 99 1%. So they have here as 0.1. But this is mostly used for giant data sets, for like data sets that are like 2 million rows, 5 million rows, like to the point where like 1% of this data set is like 50,000 rows, you know? But for our data set, it's actually pretty small, so we won't use this. It won't be sufficient enough for us to test our data well. So after we split our data, we want to actually create our model. which is called the SVD model. And we're going to fit it into, we're going to fit our training set into this model. And I have a spelling mistake. Make sure. Okay, here. And what we're going to do now is we're gonna test the model. So what it does is if it fit what this fitting method does is that it trains the data on this model. Basically, what it does, we're gonna use this training set to train our model, and then what we're gonna do is that we're gonna make a predictions variable, and what we're going to do is that we're gonna actually test our data. So we're gonna pass the other variable which we have is the test variable. Sorry, the test data right here. And yeah, just to quickly, I just want to go through this quickly again, if some people missed a point or two. What the reader does is that it gives a rating scale, a unified rating scale for this model. So it gives us basically, it gives the model like a range to what to judge the ratings on. What the dataset method does, or the dataset class is, this one, is basically, it's just a different format. We need to have a specific format for the model to work. So we're using this to pass our dataset into this format. And we're passing also the reader. As you see, we saved it as R, and we're passing it right here. And we have the three most important columns here. We can add other columns, such as title and genre, but title and movie ID are pretty much the same. Ratings are the same. Date doesn't really help us. It's more of noise right now because it's not really sufficient for our goal right now, which is just to make movie predictions. If you wanna maybe predict based on seasons, maybe you can use the data set, but that's another workshop for another day. Anyways, then what we're doing is that we're training and testing the data set. We're splitting the training and test data set into two splits. So you have the train set and the test set. What we're doing is that we get the training set, and we're gonna practice on this data set. Basically, this model is gonna practice on the train set, and then it's gonna test its knowledge on the test set, which is what we just did here. This is what these two lines do. And the last thing what we're gonna do is that we're gonna use a measurement, which is called the mean squared error, basically. I'll explain it real quick. Just let's do the code first. So we are using the accuracy, which is what we imported right here, the accuracy at the start of this this workshop, and we're gonna use this basically this measurement, which is the round mean squared error, and we're gonna pass the actual values. So the predictions, basically, we're gonna pass this value in. So basically, to see if these predictions are we want to measure these values if they're correct or not. And we're gonna pass one last thing, which is verbose. And basically, yeah. And we're gonna print the results at the end. Just gonna use printf, and we're just gonna do it right. Model RMSC is equal to, yeah, we're just gonna pass it, and then we're gonna specify a specific decimal point. So we're gonna show only the first four decimal points. And we're gonna run it. Oh, damn, wait a sec. Uh, I think I just need to add one here. Oh, I have this as capital. Uh, it's all spelling mistakes, my bad. Um, yeah, it's capital. I wrote it as lowercase. Okay, so just to quickly, I just for the loads from the df method, just put it into lowercase, and for the df process, just put it into high caps. Basically, this is what I basically did. And for the quotations, I just had it here, and I just had to move it right here. Basically, I had to include everything inside the quotation. and the value that we get is 0.87. Basically, what the mean squared error does is that it compares the actual value with the value our model gives, and it compares the error percentage between how big is the error between these two variables. So, for example, if we have for example, if the actual value is 10, however, our prediction model gave us a 5, for example. So it measures how big is the error between this. So for example, if our prediction was 8, it's not really that big. Like it's actually a pretty good prediction or a pretty good outcome that we got. Or for example, if we got 2, that's a really big difference between 10 and 2. So this is what the mean squared error does. It just measures how big the error is. So for this, we actually want the squared error to be as low as possible, specifically from 0 to 1. So if it's under 1, it's actually a pretty good number. Right? That means our model is performing pretty well. So if we got 1, that means that it's actually good rating, or actually a good prediction. If we got a range from 1 to 1.5, so if the round mean squared error gave us a value from 1 to 1.5. That means it's decent, but still needs improvement. So we still need to, what we need to do if that happens, we need to go back into processing our data and see what we went wrong. Maybe our data set was missing something, or maybe some of the values here, maybe we need to try out a different test set or something. This is what we need to do if we got this number. Or if we got something above than a 1.5, then our model just performed horribly. And we have to go back and really see what we did here there. But we got 0.8, so we don't need to worry about any of this, basically. Let me just write this, maybe if someone needs it. Bad prediction. So yeah, and we're gonna come to the last part of our workshop, which is actually making the predictions. We've built the model, we tested the model, and we measured how good our model performs. Now it comes the part where we actually do the recommendations. So what we're going to do is that we're going to define a function called estimated, get estimated ratings. And this is what we're going to take. It's going to take a value called prediction. And it's going to return the estimate of this value. So prediction. Let me just. Oh, I have this. I return this. Okay, yeah. And we're gonna do is that we're gonna define another function, which is the actual recommendation function where we're gonna recommend movies in it. So recommend underscore movies. And what we're gonna do is that we're gonna pass the user ID, so the ID of the person we want to give a recommendation to. We want to pass the model that we may built. So the model that we did above, we want to pass it into it. We want to also pass the data, so other user data, so what the other users recommended or the other users' ratings, and we want to see the number of recommendations, basically. Uh, yeah, basically number of recommendations, or we can just try and just simplify the code. Yeah. So let's do now. We get this do a method called all movies underscore ID. And what we're gonna do is we want to grab all the IDs of all the movies there. So we're gonna write movies, and we're gonna get the movie IDs. Underscore ID. And we want to get we want to pass the unique method. So we want to get all the unique keys basically. We want to create another variable which is gonna be all the watched movies. We're gonna fetch all the watched movies. And what we're gonna do is that we're gonna GDG, and then we're gonna get all the user IDs. User ID. I want to equal this. Yeah, we're gonna get all the user IDs that are equal to the ID that we're the user we want to make a recommendation to. So basically, we get all the user IDs in our data set, and we want to see all the recommendations our user made. So this is what we're doing. We're grabbing all the ratings our user did. So the user that we want to make a recommendation for. And what we're gonna do is that we're gonna pass also. Wait, we're gonna do is that we're gonna pass the other variable, which is movie ID, and we're gonna do the exact same thing. We're gonna get the values of them. Well, no, not value counts. Yeah, just values. Okay. So the other thing we want to do is that we want to get all the unwatched movies or the unseen movies. Let's call it unseen. That's better. Unseen movies that that our user didn't watch. So basically, we want to grab three things. We want to grab all the movie IDs or the names of the movies in our data set. We want to get all the movies our user watched, and we want to get the movies that our user didn't watch yet. So I mean, it doesn't really make sense to make a recommendation of a movie that our user already watched, you know? So what we're gonna do is that we're gonna create a for loop, which is M4M in all movie IDs, um, in all underscore movie IDs if M is not in watched movies, basically. So basically what this loop does, it gets us all the movies. So what what the M means. M stands for movies. So we're getting all the movies of the what do you call it? We're getting all the movies from the movie ID column, but we're gonna exclude all the watched movies that we had. This is what we're gonna grab. The next thing is that we want to grab we're gonna grab the predictions. Basically, we want to do the actual predictions. So we're gonna make a variable called predictions. Uh, predictions. Yeah, we call it predictions. And what we're gonna do is that we're gonna use the sorted method, and what we're gonna do is that we're gonna pass our predictions. And we're going to use the a key for these predictions. And this is what we're gonna, well, this is why we have this first method that we made. So we're gonna call this method first, get estimate score rating, and we want to reverse this. Since it does it, it gives us in descending order, we want to give it in ascending. So we don't want to give the least rate recommended movies, we want to give it the most recommended movies, basically. Reverse equal true. To make a spelling mistake. Hopefully I didn't. So I guess we'll find out when I run the code. Um, basically, yeah. So another thing, we want to get all the top movie IDs. So we already made the prediction. We just want to get the movie IDs for these predictions, basically. Top movie IDs, which equals, we're gonna do the exact same thing here that what we did with the loop, but we're gonna grab the IDs, basically what we're gonna do. So for every single ID in predictions, uh, yeah, basically that's that. So we want to grab all the predictions. We want to grab all the prediction movies. We're gonna grab their IDs, and we're grabbing them all the way from zero to the specified number. So basically, if we specify the top five, we'll get only the highest five. If we specify eight, for example, the top eight most recommended movies, we're gonna get the highest eight. This is what it basically does. And the next thing we're gonna do is that we're gonna get the rated movies. Basically, this is what we're gonna do. So what we're gonna do is that we're gonna do ranked underscore movies, and we're gonna turn this into a data frame. Um, just gonna do that, and we're gonna get all the movie IDs. I have to put this in quotations. So yeah, we basically turn this dictionary that we have into a data frame that we can actually use, or we can actually manipulate. And there comes the last thing is that we're gonna return the ranked movies. So this ranked movies, and then what we're gonna do is that we're gonna merge it. We're gonna merge it with the other thing, which is the movies that we got. Um, dot on. And we do the exact same thing that we did above right there. What we did all the way back, where we merged it based on one column. So we're merging it based on movie ID. Just the one last thing, which is we're gonna merge it starting from the left. And yeah, and that's that. That's our method done. So what we're gonna do now is we're gonna actually try this method. We're gonna try it out, and we're gonna see if this actual method works. And I didn't make a spelling mistake. Uh, model one dot model. What we're gonna do? So we pass the user ID. So the user ID number one or two. I'm just trying out one, and we're gonna pass the model that we made, which is here. We're passing this model into here. Next, what we're gonna pass is we're gonna pass our data set, which we named DF. And the last thing we wanna pass is the movies. So the data set we use, which is movies. And we will specify the how many movie recommendations do you want. So do we want the top five or top eight or the top 10? So yeah. So let's run this. And wait, yeah, one sec. I, oh yeah, it's a spelling mistake. I think I missed something. Oh, I didn't pass movies here. Okay, yeah. I have to pass this also. Basically, yeah. Let's run this. Huh. Okay, watch movies DF. And if I do this, so wait, let me just look at this real quick. So DF, and what we're gonna do is we're getting the value of DF. You're getting the value, and then we're gonna pass the movie ID. Huh. Let me just see the answer right here. I just want to compare if I did anything wrong. Let me just, because I know for certain this code over there works. So let me just do that. Okay, what the hell? Huh. Well, let me just see. Just sorted. Predictions. Key equals get. Okay, just you don't get estimate. Hmm. The prediction value. Could you just give me a second to look at the code real quick? I think I'm seeing something right here. The predictions, I think maybe I messed it up from here, maybe. Even though it's from outside the code, let me just check. Or it's from here. Huh. Let me see, let me just grab it from here. Uh-huh. But let me just, if you guys give me a second to troubleshoot this, let me just see something. Okay, so I found the issue. It was originally in the predictions. It was originally on here from the predictions model, from the function. So now that it works, I can see that I made recommendations for the ID, user ID basically. So, for example, for user ID number one, it gave the recommendation of Shawshank Redemption, Doctor Strange, Maltese, which I don't even know, it's the film and mystery genre, Mary Poppins, and 12 Angry Men. The problem was in this original the function. So yeah, this is basically it for the model, for the prediction model. Go ahead. Go ahead, Binyam. Sorry for butchering your name. If you can go ahead. If anyone has other questions, please go ahead. Let me know. Okay. So, sorry for reading it too late. I didn't really have it open. Yeah. Okay. Perfect. Does anyone here have any questions on this? Does everyone, does everything work for you guys? Hmm. Can I get any thumbs up just to see if you guys are actually there? Just to see. Okay. Okay. So yeah, that's basically that for our workshop today for the movie recommendation model system. This workshop will be recorded, and it already is recorded, and we're gonna post it on GitHub with the code, with everything. Actually, the code I'm gonna post is a little bit different on GitHub. It's gonna have more comments. It's gonna have no spelling mistakes this time, I assure you. And I'm gonna have like a small document explaining every single line of the code. So if you guys have any problem, if you want to check out the SVD model that we have right here, if you want to go into depth a little bit more, I actually have a link to the actual model and how it works and the matrices that it involves. So yeah, that's basically that. Again, does anyone have any questions if you want? You can shoot right now. All right, perfect. So that's that for today's session. Thank you all for attending. Um, If you guys have any questions, you can reach me out. We can reach out to GDG, our WhatsApp group. Yeah, and basically, yeah, you're free to leave if you want. You're gonna get your certifications, I'm pretty sure at the end of this week. Yeah, you're welcome, guys. It might have been a little bit too heavy. I'm sorry if you're still new to Python. This might have been a little bit too heavy. But yeah, I'll try my best explaining it to you as much as possible. And again, if you finish this workshop and you review the code again, if you have a question, you're more than welcome to ask me again. I'm more than happy to explain to you again. So yeah, that's that. Thank you all for attending.